Our last area for the study of surface areas is the surface area of spheres. Surface areas of spheres is, a sphere, first off, is the locus of all points in space equidistant from a given point, the point being the center. So in this picture, we have a sphere which would be called sphere D. Part of that, we have something called the Great Circle. The Great Circle would be the largest circle you can draw around that sphere. We can think of it as being finding the diameter of the sphere and then creating a circle which would touch both ends of that diameter. What is this? Well, a lot of people would call it a half circle, but what we actually should call it is a hemisphere. If you remember from your study in geography from social studies class, a hemisphere would be half the globe. And if you look at this, it looks a lot like half a globe. Here's a question. In the figure, O is the center of the sphere, and plane P intersects the sphere in a circle R. So it kind of slices through. If OR is 6 centimeters and OS is 14 centimeters, find RS. What we can use here is once again the Pythagorean theorem. So we know that OS is 14, OR is 6. We can do 6 squared plus B squared equals 14 squared. So using the Pythagorean theorem, I think you're starting to see is quite useful. So we have 36 plus B squared equals 196. Subtracting that 36 across, and you get 160. Now hopefully you remember how to do simplified radical form, as we've done that quite a few times now. Square root of 160 could be 16 times 10, or 4 root 10. We now have our distance from S to R. Surface area of a sphere is a rather simple formula. The surface area is just simply 4 pi r squared, where r is the radius of the sphere. Find the surface area of a rubber softball with a radius of 7.3 centimeters. We're going to use the surface area of a sphere formula, which was 4 pi r squared, if you remember. So we simply replace r with 7.3. Now, this question is already going to have some decimals in it, so I'm not going to worry about leaving pi in my answer. I'm simply just going to take 4 times pi times 7.3 squared. So we do 4 times pi times 7.3 squared. Hopefully that makes sense how we're doing that. Once you do that, you're going to get an area or surface area of 669.66 centimeters squared. That one's pretty easy, right? Find the surface area of a sphere that has a great circle with an area of 38 inches squared. First off, we need to remember the area of a circle is pi r squared. We know the area of the great circle is 38 pi, or 38, so we need to solve this. The first thing we're going to do is divide by pi. Now I'm going to leave that just as it is and get it to the point where I have 38 over pi equals radius squared. Now I'm going to take the square root. So on my calculator, all at one time, I'm actually going to take and put parentheses around 38 pi, and I'm going to take the square root of it. In doing that, I'll get 3.477 or 3.48. So now I know a radius, but I'm not going to clear my calculator screen. I'm going to leave that right there, and you'll understand that why in a little bit. Now to get the surface area of this, I do 4 pi r squared. But in my calculator, I still have r. And if you remember from a little bit ago, I had a square root formula. So I'm going to show you this in 2 different ways. But the first thing I'm going to do is on my calculator, I'm going to hit the square button. That will immediately take that long decimal answer and square it. Then that I'll take times pi, and finally take that times 4, and I'll have my answer. And if you have done that all correctly, it actually will end up being 152. And we're inches squared. But I'm going to show you something else, that as we work with the math, we should be able to get better at this and be able to identify things. And that is back here, at this step right here, I already knew what r squared was. Surface area of a sphere is 4 pi r squared. Well, what I could write here is 4 pi. I already know that r squared is 38 over pi. So I'm actually going to substitute r squared, which I know is 38 over pi, in for r squared. That works out really well because the pi's can cancel, and I'm left with 4 times 38, which is 152 inches squared. Much easier than trying to do all of that work on your calculator. Our last question, find the surface area of the hemisphere with a radius of 3 feet. So let's start with the surface area. 4 pi r squared, 4 pi 3 squared, or simply 36 pi. But that's for an entire circle. We only want a hemisphere. So we're going to take that, 36 pi, and divide it by 2 and get 18 pi. Looking back at a hemisphere, let's see what a hemisphere looks like again. The hemisphere is this green kind of bowl area plus this top piece. That's what we need. So far, we've only found the part that kind of goes around the bowl. Kind of, you could think of it as you're peeling a grapefruit or an orange, and you found half the peel. Now you got to figure out the top part. We find that top part simply by doing area of a circle is pi r squared. We know the radius is 3, so it's pi times 3 squared, or 9 pi. Now we have the bowl shape of it, so we have this piece, and we have now just figured out the top part, the part that actually makes the circle, that part that I just colored in green. So we need to combine those two together to get a final answer of 27 pi. And we were in feet squared. That's the end of our study on surface area. We'll have a test coming up soon, so make sure if you have any questions on any of this that you didn't understand, bring them to class and I'll help you out.